pressure. This sole is resting on a sterile towel for assessment. When the pressure map loads, we can see how weight is distributed across the plantar surface. Red zones at the heel and under the big toe reveal the highest load, more than 600 kilopascals, matching the areas of thick callus.
Here, the heel is covered by a compact callus. Its surface is dry and tightly packed with fine cracks that resemble a mosaic. Each line represents a point where the skin has lost flexibility. A stainless steel file is drawn across the area in slow, deliberate path.
Each time the heel bears weight, the outermost layer of skin, the stratum corneum, compresses like a resilient cushion. The pressure compacts dead cells together, squeezing them into a tougher shield. Over weeks of repeated loading, this shield grows denser and thicker. The body is built
on the ball of the foot. Years of pressure build a shield of thickened skin we call a callus. Each layer is compacted, dry, and slightly brittle, nature's way of guarding the soft tissue beneath. Under neutral light, the ridges and concentric rings become clear.
When the foot hits the ground, friction begins here, at the heel strike. As weight rolls forward, pressure shifts toward the medial and lateral forefoot. These zones bear the brunt of rubbing from both motion and footwear design. Along the outer edge of the arch, sliding contact.
Under magnification, the heel reveals a landscape of intersecting lines and tiny peaks, areas where dead skin accumulates. The scalpel is drawn across at a shallow angle, just enough to catch the outermost cells. Each pass is deliberate, controlled.
Here, a surgical blade glides under the outermost callus. What looks like a single solid patch is actually a stack of dead keratin cells compressed by pressure. As the layer peels away, the graphic on the left reveals its structure, dry, compact cells above the height.
Here, the thickest portion of callus has already begun to lift. Using fine-tipped forceps, we grasp the edge of the sheet. The keratinized layer is rigid, almost like thin plastic. As we draw it back, the underside reveals healthy, hydrated skin.
Under neutral, even lighting, the contrast becomes clear. On the right side of the heel, the untreated callus measures just over 5 millimeters, dry, compact, and pale. Slide to the left, and the treated area thins to a little more than 3 millimeters, its surface hydrated.
Our heels bear more weight than any other part of the foot. When this pressure funnels into narrow zones, here along the medial edge, and here at the lateral rim, the skin responds by thickening. Over time, repeated compression against hard surfaces, and the shearing that happens with every step.
A thick callus like this one forms through repeated pressure. Here, a single intact layer is teased away with a scalpel. The blade slides beneath the compact skin, freeing it from the soft, healthy tissue below. Lifted in one smooth motion, the slab reveals new
Using a sterile scalpel held almost flat to the skin, the outer calloused layer is coaxed away. Notice how the blade glides just beneath the surface, and the layer separates cleanly in a broad sheet. Each pass reveals the hydrated, healthy skin beneath while preserving its integrity.
This heel began with a compact 3 millimeter callus. After careful debridement and hydration, the surface is now uniform, supple, and protected. The contour map shows the dramatic reduction in thickness, from multiple elevated ridges to a healthy, near.
With exfoliation complete, the forefoot reveals its natural texture, soft, even, and free of rough patches. The skin reflects light uniformly, a sign of balanced hydration and healthy turnover. Each toe moves easily, showing the pliability that comes from proper care.
After treatment, the foot is placed on a pressure plate to evaluate load distribution. Balanced colors across the heel, midfoot, and forefoot indicate even support. Dynamic mapping reveals how the arch now absorbs more than half of the body weight, easing.
Dry skin tends to build first along the rim of the heel where pressure is greatest. In a clinical setting, a fine grit rotary file is used to delicately plane away the tougher outer layer. Short passes prevent heat and keep the surface even.
After exfoliation, the skin around the toe joints reveals its natural texture, supple, hydrated, and free of buildup. Here, the curved end of a stainless steel pusher glides under the proximal fold with minimal pressure. A soft brush clears away residual flakes, leaving the nail plate smooth.
Comparable healthy skin starts with balance, clean, hydrated, and protected. Here, a thin layer of botanical gel is applied to the sole. It delivers moisture without leaving a residue. Gentle buffing with a soft bristle brush stimulates circulation, and post-treatment, the heel displays a finely balanced texture. The outermost layer of skin is uniform, matte, and pliable. No residual dryness, no cracking. Under neutral light, billions of minuscule ridges scatter the reflection.
Working around the base of the nail, the cuticle is gently lifted and rolled back. This keeps the nail bed clear and helps prevent buildup. A fine glass file shapes the edge in one direction, reducing splitting while preserving strength. dust is brushed away,